Today we're going to focus on our inequalities. All right, so we'll be seeing absolute values with a greater or a less than. All right, now I have a play on words. I'm going to come back up to this to help you memorize which one's an and which one's an or. But here's an example to take a look at. If the absolute value of x is greater than 3, this is what your answer would look like. Okay? X could be greater than 3. So an open circle on 3 shading this way, right? 4 is greater than 3, 5 is greater than 3, 6 is greater than 3. But you'll notice it also has to include the numbers less than negative 3. Why? If I pick, for example, negative 4 and plug it in, the absolute value of negative 4 is 4, and 4 is greater than 3. So anytime you see a greater than symbol, you're going to see me write it like this. And I'm not misspelling. Greater, or. Anytime you see a greater than symbol, you're going to have an or compound inequality. So you would have x is greater than 3, or x will be less than the negative 3. And again, that's because when you go less than negative 3, the digits get bigger. And when you take the absolute value of those bigger digits, they become greater than 3. Now, if you see this one, the absolute value of x is less than 2, normally we would have an open circle and shade all the way to the left, but because it's absolute value, it actually needs to fall between negative 2 and positive 2. Because if it went any further, negative 3, for example, the absolute value of negative 3 would be 3, which is not less than 2. So anytime you see a less than symbol, you'll see me write this, a less than. See the little memory trick, play on words? Anytime you have a less than symbol, you will use an and compound inequality. And remember, an and compound inequality does not use the word and, it just writes the inequalities as a string. So it would be negative 2 is less than x is less than positive 2. This is really x is greater than negative 2 and x is less than 2. But we don't write it that way, we always write it like this. So that's what the top section says, just using variables. If you have a greater than symbol, you will use our great or. And if you have a less than symbol, you will use your less than. Okay? All right, so our steps, you'll see, are really similar to what we've been doing. Step 1 is the same as on Friday. Isolate the absolute value of the expression on one side. If it's a great or than symbol, or means we're going to set up two inequalities with the word, or. So it'll always be greater than the regular number and then less than the negative of that number. Now, if it's a less than, you'll just set up one compound and inequality. Remember, this is an and, where you'll just have the expression in between the negative and the positive value. Obviously, you'll solve the inequalities and graph our final solution. Something you'll like about these, you don't have to check your answers. Okay, why? Well, an inequality has like infinitely many solutions, right? Because it shades. So you would be sitting there for the rest of your life plugging in numbers and testing them. So you don't have to check them. You'll just be, you could pick one point if you wanted to and plug it in to see, but you won't be required to. All right, solve each inequality. Step 1, isolate our absolute value bars. They are isolated. Step 2, identify if it's a great or a less than. Looking at our symbol, this is a great or. Okay. Now, be aware, if you were to move stuff on the other side, like divide by a negative, you have to flip your sign. You always want to look at the symbol right before you set up your compound. So this is an or, so I'm going to set up 2. One where 3x plus 6 is greater than or equal to 12. I'm going to use the word or in the middle. Or 3x plus 6 Now you do have to flip the symbol, will be less than or equal to negative 12. And that's because it would be like negative 13, negative 14, negative 15. The digits get bigger as it gets smaller in the negative. And then you just solve each one. Keep that word or in our final answer. And we like the ors because you don't have to put them together as one compound inequality. You just leave them as our two separates. And then we graph them. So on my number line, I'll put -6, maybe 0. You really don't have to have the 0 if you're doing a compound, but sometimes I put it on there. And we'll have a closed circle on 6, shading to the left, closed circle on 2, shading to the right. It's either less than -6 or it's greater than or equal to 2. Again, if you really wanted to, you could pick a number in the shaded region and plug it back in and see if it works, but you're not required to on these. All right, the next one, we have a little bit more work to do. We need to isolate our absolute value bars. What would I need to do to both sides to start that process? Kevin? Add 9 to both sides. Can I distribute the 3? No. Remember, the distributive property does not work for absolute values. But instead, if I want to isolate this, what do I need to do to both sides? Parker?
Divide by 3.
Divide by 3. Okay, never look at this symbol until you get the absolute value isolated, because sometimes you'll divide by negative, as I said, and flip things around. So now we're going to look at our symbol, and we can see that we have a less than, which we use a little play on words, that's your less than. So we're doing an and inequality. Now you have two choices. You can actually set up 2 with the word and then at the end take the word and out. Okay? So if you wanted to do that, this is not how I'm going to show it, but I'll put it off to the side. It would be 2x plus 6 is less than 8, and 2x plus 6 is greater than negative 8. So if you want to do it that way, you're more than welcome to. Personally, I know my final answer has to look smallest less than x less than the largest number. So what I do is I just take the 8, and I'm going to put a -8, a less than symbol, bring my expression right in the middle, and then my positive 8 here. So you just take your number, the opposite of it, and you sandwich it right around. So it's already like set up as the final answer. We just have to do a little bit of inverse operations. This is the same thing as this, but you're just not going to have to solve 2 separate. You'll solve 1 together. Whichever you prefer, I don't care. Okay, so you can either do this or you can do this. And then we still have to solve. So we're going to subtract 6 from all 3 pieces of the inequality. And then we'll divide by 2 everywhere. So we'll get -7 is less than x, which is less than 1. Again, if you do it this way, you'll get 2 answers that you'll have to then put together to make it look like this. And then to graph this, -7, 1, open circle on each one, shading in between. All right, I want to change the next example. -3 times the absolute value of 2x minus 3 is less than -21. What do I do first? Okay. Divide by -3. Very good. What do I have to remember to do when I divide by a negative? Aiden?
Flip the symbol.
Perfect. Flip your symbol.
So now it'll be less than, right?
Right now, it's a less than.
Right now, no.
And when I flip it, it's going to become a greater. Okay, now you'll notice it looks exactly like the original question was, but I just added that in there to remind you that that can happen. All right, now we read that this is a greater. So we're going to set up our compound inequality with the or. 2x minus 3 is greater than 7, or 2x minus 3 is less than or equal to negative, or excuse me, less than, not equal to, negative 7. And solve each one. And graph your solution. Make sure that if you use an open circle that on your test I can clearly tell it's not filled in. So kind of make it a little bit bigger so that I can tell it's not a filled in circle. I'm not grading those. So we have x is greater than 5 or x is less than negative 2. All right, last one. Someone I haven't heard from yet. What would I do first here? David?
Subtract 2.
Subtract 2, you got it. And then which type am I setting up? An or an and? An or an and? Connor? Good, this is a less than. Okay, so again, you have your option of setting up the 2 with the word and in the middle, or just take the opposite, which would be negative 8, and stick that on the left with a less. It will always be a less than symbol. Stick your expression in the middle, 4x minus 12, and then a less than 8. I should say it could be a less than or equal to, depending on what the problem is, but it will always be a less than. Remember, this is like the Pac-Man eating the bigger number. Okay, so they're always going to go that way when it's an and. And then we just solve this. Remember, whatever you do to one piece of this, you do to all 3 of them. Again, I personally like to do it this way because it's less writing than setting up the 2 separate, and your answer's already then in that form that you want it to be. And then we graph it. Okay. Leads us to our closure. I'd like you guys to go ahead and let's treat this as a little mini partner challenge. Okay, so get together with a partner. Again, if you want to work alone, you can. I'd like you guys to complete this problem. And when you're done, come up and show me. I'll check it to make sure you got it right. And then you can begin on the homework, which is again on Google Classroom. Don't forget, your chapter test is on Wednesday this week. 70 points, no calculator. If you want to start studying, because the homework tonight isn't very long, you could start on the chapter review. The chapter review is just from the book. It is not going to be exactly like your test. It's just a sampling of all the types of problems that we've seen. But I would suggest when you're studying for your test that you go back and re-study your notes and your homeworks. So homework questions are all fair game for the test. So any ones that you really struggled on with fractions, those are probably going to be on the test. So make sure you're studying all the questions that you had in your homework. I will tell you that there are a lot of fractions on the test.